So right now we have our image being drawn, our background image. We have some text being drawn on top of that. Let's go get our mushroom set up. So back up top, inside of our load content, I'm going to set up my mushroom. Very straightforward. There's no overcomplicated things here. I need to set my destRec for my mushroom. So mush image dot destRec is equal to a new rectangle. And a rectangle is defined by an x, a y, a width, and height. So we're just going to make up some numbers here. I'm going to put it at, let's say, 300 pixels over and 400 pixels down. So since my screen is 800 by 600, that means it's a little less than halfway across the screen and a little more than halfway down the screen. So now I need the width and height. Now, if you recall, when I looked at the image was exactly 32 by 32 pixels. So I could draw it the way it was meant to be if I'd like. So if I do that, and then I come down here and I copy and paste our draw code, but change our BG image to mush image, we should get it on the screen exactly the way you would expect, except it's pretty tiny. It's really small. It's smaller than it should be. In the real game, the mushrooms are about the size of one of these squares. So we would have to deal with that. Now, first of all, we got some magic numbers here. This 32 and 32, they are definitely magic numbers. We don't really know what they represent. Well, we don't officially by looking at the code. But we know that it actually represents the real width and real height of the image. The cool thing is that we can actually retrieve that data. So again, just like we did with the screen width and screen height over here, we can do the same thing with that individual image, since we loaded the image before we tried to set up the destRec. So instead of 32 here for the width, I could write mush image dot get frame width. I'll go into what a frame means later on, but for now just realize that it gets the current width of the individual image. So similarly, I'm going to do the same thing for the y value, so the height. Sorry, not the y value, the height. So mush image dot get frame height, and that will return the actual height of the picture itself. Now if we were to run this program, we should get the exact same results we did a second ago, and we do. It's the same size, it's in the same location, nothing's really changed. Now what if I wanted to scale it? I wanted to change its size. Maybe I want it twice as big. All I have to do is multiply its width by 2. And that would give me twice the size. Same with its height, if I want it to be nice and consistent. Now the problem is that assuming I multiply it by a whole number, that's not an issue. But if I want to multiply it by something like 2.5, all of a sudden it's a problem, because what it does is it turns that width, which was an integer, into a double. So that means that I'm looking at a number that doesn't match our rectangle, because our rectangle requires 4 integers, not an integer, a double, and a double. Which means we need to do a little conversion. We're going to convert or cast our results here into an integer. So I can surround that whole thing in brackets, and then I put the int in front of that, and that will remove the problem for that one. We're going to do the same thing for the height value as well. Alright, so you can see that the error is gone because now it's an integer. Basically, it's going to cut off the decimal place if we end up with a decimal. So we're going to run our program, and we should get a picture that's 2.5 times its original size. And we do. Quite big. Quite big. We don't have to only scale up. We can scale down too. Maybe I want it to be half the size. 0.5 and then 0.5. Oops. Save it, run it, and we get a tiny little mushroom, as you can see there. So we can scale in either direction, and it produces effective results, things that we want. That should be about it for this, for the destination rectangle. What's cool though is that I can reuse something like my mushroom image and just draw it multiple times on the screen. Let's say, for example, I wanted another mushroom. All I would need to do is create a second sprite sheet. So the second sprite sheet is basically going to set up the image again. Now the system is only going to load it once, so it's okay. But when you set up that sprite sheet, you're going to be able to set up all the custom width and height of it, and you're going to be able to draw that mushroom as many times as you want. You just got to keep calling the draw.sprite on each different sprite sheet you have. You might have a whole array of mushrooms if you really wanted to in your game, but that is a possibility. Finally, I just wanted to go over a few different cool things that we can do with our sprite sheets. First of all, let's modify some stuff. I'm going to show you a few different commands. So let's play with our mushroom, but we're going to put it back to 2.5 times just so it's a little bit easier to see. Don't forget that we can change one of those values if I want. If I only change the width to 2.5 times but keep the height at tiny, what happens is you get a vastly skewed mushroom here. That is an option if you want to go that route. It depends on what you're doing. Sometimes it's useful. Now, what are the commands I can do with my sprite sheet? I've got 5 main commands. So if I have my mush image and I hit the dot, I'm going to see a whole bunch of different things I can do. The first one is I can rotate it. If I rotate, I can say delta angle. Delta, if you remember that from science class or math class, it means change. How much do I want to change it by in degrees? So for example, if I want to change it by 5 degrees, it's going to rotate it 5 degrees from whatever angle it's currently at. So if we run this and hit the program, hit the run, you can see we get a slight tilt on it. 5 is not very much. Let's say 10. And we run it again. We get a much more tilt to it. You can actually see it. It's quite a bit more obvious. Similarly, instead of rotate, we also have a rotate to. So instead of rotating by a certain number of degrees, we can rotate to a specific angle. So let's turn it on its side and rotate it to 90 degrees, and hit F11, and we get it fully on its side. Not only can we rotate, but we can also flip the image. Now this is going to be a little bit difficult to see, so let me just write it out first. So to flip it, I just write flip horizontally. I don't need any parameters at all. I just call the flip horizontally subprogram. And I hit F11. Now you might be like, how do I know that it's flipped? Well, take a look at the current look of it. We have that little line there. Now let's take it away by commenting out that line of code and run it again. And now we can see that everything is on the opposite side. So we've flipped it horizontally. Similarly, we can also flip it vertically, which means it's going to flip it in the x-axis. And we get an upside down mushroom. Yay, wonderful. And the last one that I really wanted to show you, probably the most useful one, is set transparency. Set transparency. And now it's going to be a number in between 0 and 1, and it's going to be a float. So if I set this to say 0.5f, we should get a mushroom that you can see the sky behind it. And we can. What we can do that's really cool though is we can start to do these types of techniques inside of the update code. And if we do it inside the update code, we can end up with some much more interesting results. So down in update, what I'm going to do is I'm going to say mush image dot rotate. So this is rotating by a certain amount. I'm going to rotate it by 2 degrees. Not very much. Now watch what happens. It's actually continually rotating. Why? Because it's an update. An update happens 60 times per second. So since I'm rotating it by 2 degrees, in 1 second it's going to rotate a total of 2 times 60, which is 120 degrees. Pretty cool. Now we can do that with all of our stuff. We can do things like flipping and transparencies and all sorts of fun things. We can scale it, we can change the size, we could even move it around the screen if we wanted to, just by changing its destrec X value or destrec Y value. We could modify those values and we could get it physically moving all over the place. So for example, I could say BG image dot not background, let's do the mush image dot destrec dot x is equal to mush image dot destrec dot x plus 1. Basically, I'm saying add 1 to the current value of x in the destination rectangle and store it back in the destination rectangle. Now when we run it, we get it moving away and rotating simultaneously. So we can create some pretty cool effects with this, very easy. Now of course this is a lot of code. Remember that we can use the plus equals option, so instead of writing that whole thing I could just say plus equals 1, and we end up with the exact same thing of it rotating away, and much easier code. So that's how we can load our images, display our images, both background, how we can customize the size, and all these different properties of every one of our images. You're going to find this to be one of the most useful tools we have in our game making.